Hello and good day everyone, especially to my respected panels. My name is Hanzzel Anararaki Charles with student ID of B0919103339. Today I am here to present my final year project 1 entitled Low Cost Anti-Theft Security System using IoT approach for motorcycle. Currently, I am pursuing my degree under the course Bachelor of Mechanical Engineering Technology, Automotive Technology with honors. This project is supervised by Mr. T.S. Khairul Azri bin Azlan. Before starting, let's look at the contents. The content of this presentation will begin with the introduction, followed by problem statement, objective, scope of research, literature review, methodology, and finally, preliminary result. Let's begin with the introduction. Now, I will further explain about the analysis of motorcycle theft in Malaysia. According to the Vehicle Thief Reduction Council of Malaysia Berhad VTREC, an average of 20 vehicles were reported stolen daily in 2020. On average, about one motorcycle was missing in 26 minutes. Let's move on to the project planning. This project has been proposed to increase the security system for motorcycles by using RFID authorization. This system also consists of a global system for mobile communication module and a GPS tracker. A vibration sensor is also fitted in this system to detect shock or force that is possibly caused by the intruder's tampering with the motorcycle. Next is the problem statement. Although modern motorcycles have more advanced technologies, theft of motorcycles keep on increasing throughout the world. Motorcycles are now very easy to steal simply by opening the ignition keys with a single key, especially low-powered motorcycles. Therefore, there is a need to propose and design an anti-theft security system to alert motorcycle owners remotely using GSM and immobilize the engine when the thief try to steal the motorcycle. Next, I'll further explain about the scope of research. The first scope is design and develop a motorcycle anti-theft security system that is capable of alerting the owner from remote location. The second scope is using GSM and Wi-Fi module as a communication platform for alerting the owner via alert messages and phone calls. The third scope is using the radio frequency identification, which is also known as RFID, as the authority detection purpose. The fourth scope is using a microcontroller as the primary source of the system. The fifth scope is perform analysis on the device power consumption. The sixth scope is enable motorcycle tracking through a GPS tracker. Now, let's look at the research objectives. The first objective is to design a motorcycle security system using RFID and Android application to increase the security level. The second objective is to develop the connection between the design security system and the Android application functionality. The third objective is to develop the system prototype and perform a functionality test. The next part is the literature review. I will further explain about different types of motorcycle anti-theft security system that had been already developed and also existing in the market. Firstly, I will review on a project entitled Motorcycle Security System using SMS warning and GPS tracking, which was developed by Artono in the year of 2020. The system uses SMS gateway function and also a GPS tracker device. The next review is on the face recognition for motorcycle engine ignition with messaging system, which was developed by Austria in the year of 2017. This security system can recognize the faces of registered users and ignite the engine. The following review is on the anti-theft fingerprint security system for motorcycles using Arduino Uno GPS and GSM module, which was developed by the CS Group in the year of 2019. In this system, a fingerprint sensor is used to increase the security system for the motorcycles. The next review is on the motorcycle security system using GSM and RFID, which was developed by Ariel and Maharjan in the year of 2019. This system uses passive RFID as a secondary key to start the motorcycle. The table below shows the comparison between different types of Arduino and their specification. So through this comparative study, I was able to choose the correct type of Arduino to be used in my project. Next, let's look at the formula. The formula used in the security system is to calculate whether the battery capacity can provide a sufficient power for this design security system during standby mode, even though the motorcycle is parked for several days. The battery capacity reading must be in the value of watt hours. Formula 2.1 shows the watt hours calculation, which will be used as the main formula in this project. The others, the other formulas are the sub-formulas, which is to calculate the charge capacity, energy capacity, Ohm's law, electric power, and also the power. The next part is the methodology. Let's look into the project flowchart. First of all, I studied various reports on motorcycle thefts in Malaysia. Through this, I was able to gather a lot of information. Next, I carried out literature review on various resources to widen my knowledge regarding my project scope. Besides that, I also carried out comparative studies on different systems to gain some ideas so that I can implement in my project. After that, I planned and developed the system architecture and design. Through this development, I was able to plan the prototype of the system. For the implementation of the system, I used the Tinkercad, Freezing, and Circuito.io software to construct and simulate the system. Through this, I was able to identify the ability of Arduino Uno to integrate with the Wi-Fi module, RFID, and GSM module. Through all the aspects stated above, I was able to evaluate my project. Finally, within week 14, I was able to complete my report. Next is the House of Quality. The House of Quality, which is also known as HOQ, is used to define the relationship between customer requirements and the capability of a product. Before developing the HOQ, I conducted an online survey via Google Forms in order to require customer feedbacks. Based on the customer feedbacks given, I was able to convey the customer feedbacks into the HOQ to relate customer requirement with engineering requirements to develop my project. The figure below shows the interaction matrix. The interaction matrix displays the coloration analysis for each corresponding engineering requirements. As we can see in the figure below, the design aspect has the highest strong positive coloration among the others. Let's look into the morphological chart. The morphological chart captures the necessary product functionality and inspects several approaches and combinations to reach that functionality. This morphological chart is necessary because it combines each element from different kind of aspects to become one acceptable concept for the end product. Through this morphological chart, I was able to select the best concept which contains the preferable elements that I plan to be used in my project. Next, I'll further explain about the PAC method. The concept evaluation is achieved by using the PAC method. PAC method is a decision matrix that helps developers in concept decisions by establishing a procedure to choose the best concept from the considered different concepts. This analysis is done based on the selection made on each element for three different concepts according to the morphological chart. Several ideas were obtained from the PAC method concept evaluation chart above to build the motorcycle anti-theft security system. Next is the system architecture of my project. The architecture system is constructed with aided figures to easily understand, and it will be very helpful when constructing the circuits of the system. This system consists of hardware and software mechanisms. The hardware mechanism is built with microcontroller as the primary source and communicate with other components like the Wi-Fi module, GSM module, RFID, countdown timer, vibration sensor, and the relay module. Regarding the software mechanism, the Arduino Uno R3 will be programmed using the Arduino Integrated Development Environment to enable the functionality of this anti-theft security system. So now I'll further explain about the system flowchart. As we know, generally this system uses the RFID. When the owner presents the RFID tag near to the RFID reader, the RFID reader should match the unique ID code and disarm the system. The RFID tag should be around 1 meter from the motorcycle to enable it to start. Then the correct key is used to be detected by the engine mobilizer in order to start the engine. Besides that, this system consists of a GSM module to alert and send warning messages or call the owner directly. A GPS also installed in the system to provide a real-time location tracking of the motorcycle. A vibration sensor is fitted in the system to detect shock or force that is possibly caused by the intruders tampering the motorcycle. If the motorcycle is stolen, the owner can send security commands through the mobile application installed in the mobile phone to stop the engine. In case there were no security command received, this system has been designed to cut off the fuel supply automatically. Besides that, at the same time, the alarm will also be triggered and the captured images will be sent to the owner through the mobile application. Now, let's look at the components and equipments that will be used in this project. First of all is the Arduino Uno R3 as the main primary source in the system. The GSM module is also used to send warning SMS and also make phone calls to the owner in case of any theft occurs. Besides that, Wi-Fi module is also used to send images to the owner as the GSM module itself can't accomplish this action. The DC to DC step-down converter is also used to step down the higher input voltage directly from the battery to prevent damages of the components in the system. The Arduino countdown timer is used to count down 30 seconds before it automatically cut off the fuel supply in case there is no any security commands received from the owner. The relay module is basically acts as a switch in this system. Besides that, the vibration sensor module is also used because it has the capability of detecting excessive vibrations or shock in the system. The buzzer is also used in the system to provide sound in case of any unauthorized engine starting to alert the surrounding people. The GPS tracker is used in the system, which allows the owners to track their current location of their vehicle in case their motorcycle has been stolen. RFID module is used in the system as the main authorization access in order to start the engine. The camera module is also used in the system to capture the images of the thief and directly sent to the owner through the mobile application. Besides that, the fuel shutoff solenoid is also used because it has the capability to cut off the fuel supply from the fuel pump. Next, let's have a look on the RFID circuit and their coding. One of the main important circuit in this motorcycle anti-theft security system is the RFID authorization circuit. The figure of the circuit diagram consists of Arduino Uno R3, RFID card reader, 5 voltage relay module, buzzer, transistor, and a resistor. This circuit was designed in the Circuito IO software. The next part is the preliminary result. First of all, let's look at the expected results. This anti-theft security system is expected to use the RFID as the authority detection purpose. This system also consists of a vibration sensor in order to detect excessive vibrations and can send warning messages and phone calls. This system should also enable the owner to track the location of the stolen motorcycle. Now, I'll further explain about the problems encountered. The Tinkercad software is used to construct the circuit and also to simulate it. However, components such as the vibration sensor, GSM module, and Wi-Fi module are not available in the built-in library of the components in the Tinkercad software. However, this problem is overcome by using the freezing software and also the Circuito.io software. However, the circuits constructed cannot be simulated in these both softwares. Now, let's look at the RFID circuit and its coding. This circuit is constructed in the Circuito.io software. This circuit system consists of Arduino Uno R3, 5 voltage relay module, RFID card reader, GSM module, mini push start button, and a buzzer. All the important components required in the system is included in the circuit diagram. This is the Gantt chart of PSM1. The Gantt chart shows the main activities conducted in 14 weeks. The yellow color represents the plan, while the green color represents the actual. That's all from me. Thank you for lending your ears.